Hello students, previously we have discussed the pure resistance, pure capacitance and pure inductance circuits. For that voltage, current and power equations we have seen. Now we will discuss the series RL circuit. You can see here. This is what the first figure 1 of series RL circuit. In the other circuit we have series RC circuit. Okay, this is what figure 2 RC circuit, series RC circuit. Okay, now if you observe KVL here in this circuit, if you apply KVL, then what we get here? The supply voltage V is equal to voltage across the resistor plus voltage across the inductor. While you apply voltage across the inductor, you should also take the phase angles, because we are dealing with the AC calculations. So here magnitude as well as the phase angle should also be taken care. Okay, I hope you understood this point. Magnitude as well as the phase angles. That is nothing but, what is the resistive phase angle will be? Definitely 0. What is the voltage across what is the phase angle for the inductor will be? 90 degree. Hope you understand this point. Now what is the voltage? According to Ohm's law, voltage is nothing but current V is equal to current and impedance. As I already said, impedance is a combination of resistance and inductive as well as capacitive reactances. I into Z is equal to, what is the voltage across the resistor will be? I into R. What is the phase angle here? 0 degree. Plus voltage across the inductor will be I times into XL. What is the phase angle here? 90 degree. Now if you simplify this, what we can common from this point? R at an angle 0 plus 1 at an angle 90 degree. 1 at an angle 90 degree can also be written as 1 at an angle 90 degree is nothing but J vector. So this J vector is multiplied for the XL, J into XL. Hope you understand this point. I into Z is equal to I times R plus JXL. What is Z? We can write here. Simple. R plus J into XL. Okay. This is what the Z value. If you want to find the magnitude of Z is equal to, magnitude of Z is nothing but X square plus I square. Means you can write, let me change the ink here. Magnitude is nothing but under root of real part square plus imaginary part square. Okay. Now for this, if you draw a voltage, impedance and power triangle, voltage triangle will be this way. If you take the resistance as a reference here, this is what we are. How this VL will be? VL is taking at an angle of 90 degree, plus 90 degree. So we get here plus 90 degree. Okay, this will be what? VL. Now the phasor sum will be the phasor addition of both VL and VR will be what? V. That is V is equal to VR square plus VL square. If you apply magnitude for this equation, if you apply magnitude condition for this equation, okay, then what we get here? VR square plus VL square over the root. Okay. Then what is the angle here? We have identified the magnitude here. Magnitude V is equal to under root of VR square plus VL square. In the same way, what is the angle will be? Imaginary axis divided by imaginary part divided by real part. Okay, this is what the voltage triangle is. In the same way, you can also find the impedance triangle. Impedance triangle will be, yes, impedance triangle will be in the same way. What is Z? Z is nothing but Z is equal to R plus J into XL. Yes or no? So if you take the real part here, resistance R, then XL, inductive reactance will be what? Plus 90 degree, plus 90 degree, plus 90 degree times. Yes or no? This is JXL. Or else you can simply remove this J. You remove this J and you write here, it will be what? Angle of plus 90 degree. Then the resultant part will be what? The phasor addition will be, the summation of these two will be nothing but impedance. Therefore, impedance is equal to R plus JXL. The magnitude will be R square plus XL square over the root. And what is theta? Theta is nothing but the angle will be what? Tan inverse of imaginary value by real value. Okay. For this only, this XL will be the imaginary part. This R will be the real part. Always remember, J multiplication factor will be always imaginary. In the same way, you can even find the power triangle also. For power triangle, if you take, this is what the real power. Power P is equal to I square into R. I square into R will be the first power. Then this power is nothing but I square into XL. I square into XL. And this resultant will be I square into Z. How you got these values? How you got these values? Let us take this as equation number 2. For equation 2, multiply on both sides by I. By I. Then what you get here? If you multiply I on both sides, I square into Z, I square into R, I square into XL. So that is what I have written here. Then this I square into R is nothing but the active power. This I square into XL is nothing but the reactive power. I square into Z is called apparent power. Don't worry, I will mention all these points here. Okay. What is meant by P? P is nothing but active power or real power, or sometimes it is also called as true power, or sometimes it is also called as average power, or sometimes it is also called as effective power. Okay. In the same way, what do you mean by Q? Q is nothing but the inductive reactive power. Inductive reactive power. The units of inductive reactive power is VAR. What about the active power units are simple watts. Okay. In the same way, what do you mean by S? S is nothing but apparent power. Apparent power. The units of apparent power is V into A, volt ampere. Okay, volt ampere. So if you observe the power equations, power expressions, I have not given you the magnitudes no here. So therefore, S is the total power. S is the total power or apparent power is equal to under root of P square plus Q square. P square plus Q square. Okay. Then what is this angle? Angle is nothing but tan inverse of inductive part, imaginary part divided by real part. Yes or no? Yes. Okay. So this was about the RL load. Similarly, we can even find the value for reactions for RC circuit also. Okay. Thank you.